Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I will show my students the idea of the project and how they can do the project. By the way, the project idea is we are trying to use the MATLAB application to solve a mechanical engineering problem. So we are demonstrating the ability of MATLAB application designer to solve any kind of engineering problem. And I selected a well-known problem, which is the projectile. By the way, we are here not to talk about the physics, the physical part of the system here, how we generate how we drive or generate the equations, and what are the correct equations. We have to consider the drag forces or whatever, friction. So I'm not here to talk about the physics. We are here just to talk about the MATLAB part, how we can program the MATLAB, how we can build our own application to solve mechanical engineering problem as an example. So the idea here, we have an airplane. This airplane is traveling with speed of v airplane. Inside the airplane here we have a box, and this box should be dropped say that with horizontal velocity of v0, and actually the initial velocity of the box, it is same of the airplane velocity. This is an assumption. And there is a truck is moving from right to the left, and the truck should pick the box traveled or dropped from the airplane to the target position. And as you see here, we have three possibilities. The first one, or first case, that the box and the truck will reach the target point at the same time. In this case, the truck will pick the box and no need to show the truck motion, and we have to just show the box trajectory. The second case, that the height of the airplane and the airplane velocity have been selected to give maximum traveling distance for the box in x direction, which is d, less than the target. In this case, that the truck will reach the target, but the box will not reach the target. And in this case, it should be there is some way that the driver should know that the box in this case will never reach the target. So the truck should move from this location, target location, at initial speed v t0 with acceleration at selected by user. It could be 0, that means the velocity will be constant, and it should reach this point where the box should hit the ground, and the truck in this case will pick the box before it hits the ground. By the way, in this case, the flying time of the box, it will be the driving time or motion time or movement time of the truck from this location to this location. So the time from here to here, it is same time from here to here. So they will say that come to the same point at this time. In this case, guys, we should calculate the location of the truck, which is x truck and y truck, and we know that the truck will move to the left. That means the y location of the truck, it's always same, 0. It will not travel in y direction, but it will travel in x direction. We have some equations in x direction. We have to use the motion equations to calculate the position of the truck in x direction. For the box, we have also said that the projectile equations, we can use the differential equations here to solve for the box location. Remember that the box dropped from the airplane at horizontal velocity v0 from height h, so that the initial condition for the box, the initial position when the time is 0, the x for the box will be 0, and the y will be h. Now, as I told you, the second possibility here, or case, that the d is less than target. In this case, the truck will move to the left, And also it could be that the height and the velocity of the airplane have been selected so that the D is much larger than the target point. In this case, the truck will move to the right to pick the box. I will show examples on the application. By the way, this application design not completed yet, and it is just an example to show you how we can do it and what's going on. You should not use the same. You should not do the same. I want to see your own design, not mine. I want to know exactly what you can do. Show me something very good. And also, I didn't complete the application yet. We should have more quantities that should be split here. As you see in this application, we have the target position from 0 to 500 maximum. The height of the airplane should be between 0 and 120. The airplane velocity should be from 0 to 100. The acceleration should be from 0 to 30. And the user should select these quantities. According to these quantities, we have a push button here, run, to calculate and show the motion. Make motion simulation here. I will show you how. And here we have so that push button. You could have it. You should not exactly do what like what I did. You could have this push button to show the initial conditions and also reset graph, reset data. By the way, reset all data. You can reset this one and this one, this one, by say that change the value of these objects back to 0. Reset graph can be done using the CLA function. CLA brackets app dot the user interface axis. It will CLA. It will clear the axis, so you can use it. And I will show you how we can plot. Now regarding the cases we have here again, it could be that the box and the truck reach the same target position at the same time. In this case, we should plot just the box trajectory, because regarding the truck, it doesn't matter it moves or not, because it just picked the box. Second case, where D less than T, the truck will move to the left. The third case, where T less than D or D greater than T, the truck will move to the right to pick the box before it hits the ground. Now, how we can calculate the trajectory of the box? We have equations here, the differential equations. By solving these differential equations, we get the x function of time and y function of time using symbolic equations or symbolic say that process in MATLAB. G, it is the gravity acceleration. T here, it is the time. That we know exactly also the initial condition. We have the x when time equal to 0 equals 0, and y when time equal to 0 equal h. We can solve the ordinary differential equations using the dsolve function or any type of solver. So it's easy, and these equations, it's same in 3 cases. So for the box, you can calculate them once only. No need to do it again and again for second and third case. Regarding the flying time here, it's very important to show the flying time. By the way, distance traveled by the box should be shown here, flying time and initial velocity and different things. We need the total flying time. By the way, the total flying time for the box from here to here, I told you it is same for that truck to go from here to here. So we have to calculate total traveling time using this equation. So TF equals square root of T of 2 times h over g. H, it is the height, and g, gravity acceleration. It's very important to calculate the time, because I will use this time to calculate the location for the time, and acceleration to calculate the location in x direction for the truck. I will show you how now. Now, as I told you, we have 3 cases, the second case and third case. The second case, when the target distance much or say that larger than d distance and the truck go to the left, use this equation to calculate the x and y. And the last case, when the d larger than the target, use these equations to calculate the xt and yt. We need as you see here, we need the VT initial truck initial velocity. The truck initial velocity should be calculated using this equation. Vt0 equal the absolute value of t minus d minus 0.5 times at, which is the acceleration, truck acceleration given from here, times tf, the total flank time calculated previously for the box. It's the same, divide to the power of 2 divided by tf. So we can then say that define a time vector, and this time vector should be between 0 and total flying time tf incremented by 1.1. That's up to you. And then we can calculate the x and y for the box by substitute the x and y equations at the time from 0 to say that tf to get two vectors. Plot these two vectors, and same thing for the truck. We have y's, all of the y is 0 because it will not travel in y direction, only in x direction. And regarding x, we have the time vector from 0 to tf. We can use this time vector and equation of motion I show you here and here to get the, say that the x value, xt and yt, as you see here. The t here, it is the time vector, which is from 0 to tf. After calculating the xt, yt, x and y for the box and display everything here, we have to demonstrate the motion, or say that motion, do motion simulation. So we have point here and point here, they are moving in real time. I will show you now. I will select say that very large target, small height and small value of the velocity. In this case we will get d less than t. The truck will move left to get the box. Now we can keep this one 0 if you want the truck to move in constant velocity, or accelerate it like this. Run the program. I got an error because I deleted something to show you the code. Let me stop and show you the graph without the code. Now let me select again large position, target position, small height, small airplane velocity. In this case, the box will drop and will not reach the target position, and the truck should go to the left to pick the box. Say the acceleration is 0, keep it like this, never mind. Run the program. See, this is the initial position for the box, and this is for the truck. As you see, the projectile for the box. At the same time, the truck moves to the left, and they will meet at certain point, so that the truck will pick the box. The simulation, it is little bit slow because I'm using say that I'm holding the graph and updating the graph inside the application. It is a little bit slow. If you do it in the script, it will be much better, and speed will be very good. But never mind, this as I told you, the application, it is not completed yet, and it should be fixed. Now the truck will pick the box, and then we should get say that see the box projectile and truck motion lines. I'll show you how we can do this one. We can reset the graph and reset all of the data, as you see. Now I will select low value of the target, small value of the target, higher value of the height, and higher value of the velocity. That means the height and velocity enough to say that give d larger than the target. In this case, the truck will move to the right, not to the left. See, this is the current location of the box, current location of the track. Now the track will move to the right to pick the box. Again, sorry for this is slow motion. I have to fix it. The application is not completed yet. As you see here, the distance traveled by the box, it will be 248.7 meter in 3.921 seconds. And same thing, the truck will reach this position in 3.921 seconds. And also I have to display the initial velocity that the truck traveled toward the box. Now this is the projectile and this is the truck motion. We can again reset all the data and run again, and so on. Now regarding the plot, how we can make the plot, I will show you the code, part of the code. By the way, we have here if else statement before to indicate the case, and then we will plot. As you see, again, I don't want you to use the same code. You can use your own code. By the way, you can remove P1 and P2 and these things and just plot stars and use draw now or pause. I will tell you the story of draw now and pause. Now here we are holding say that the application axis. This is the axis name. It is AXX. We are declaring a handler called P1 and the P1 value equal to plot. As you see here, plot. We are plotting the current location of the truck. See, it is T in X direction and 0 in Y direction here. And the second one, sorry, Control Z. And the second one, it is another handler for the plot. It is pointing to the plot, second plot, which is plotting the current location for the box. See, it is 0 in X direction, H in Y. Then we have the first point. We will start a for loop from 2 to the end. We are saying that P1, we are updating the value of X data for the P1 equal next X of T, xt of k, sorry, and we are updating the y data of P1. It will be the next yt of k, and same thing for the x and y. By the way, this is for the truck and this is for the box. And draw now, after updating the x value and y data for both of them, we want to use the draw now function, built-in function. And this draw now, it means update the graph now according to the new informations or new values. So it will update it. So it will show you the motion of the points. After finishing the motion demonstration or simulation, we have to plot the lines again. Again, you can remove the P1 here, X data and P1, and use just stars. In this case, you can use draw now to update the graph, or you can use the pause function. As example, pause bracket 0.1 bracket, that means pause for 0.1 second. You can decrease it or increase it, it's up to you. So pause function, it will pause the graph or the next say that command. In this case, it will show you the star after star with some pause. In this case, you will see the stars moving from one location to another one. Again, you should not use the same code. You should use your own code. Let me get back to the question again. I think everything is okay. These are the equations for the airplane, and these are the equations for for the truck. I hope that everything is clear. If you don't understand everything and you need more clarification, we can meet using the iLearn or the Zoom or the Google Meet to make things more clear and clarify your or sort out your issues. Thank you so much. Again, the last thing, I don't want you to do the same. I want to see your own design, your own ideas, your own code in a very good way. Okay? And this is again not complete APP. It is just an example to show you what's going on. It should be completed. Thank you so much. See you next video.